702 and Cape Talk.
The Naked Scientist.
Chris, good morning to you.
Hey, morning Eusebius, how are you?
Extremely well, thank you, Chris. There's a lovely story, particularly in relation to the importance of us men shouldering the burden as well when it comes to our liaisons with women and birth. A new potential male contraceptive technique.
Yeah, this is exciting, but I should emphasise this is only being done in experimental animals at the moment. So this is not something you're going to rush out to the chemist and get tomorrow. But basically, this is a form of chemical vasectomy. Now, the way in which people can stop themselves having babies is either by using a condom, abstaining, which is obviously not going to happen, or more radically, people go and have a vasectomy, which is where the tube that connects the testicle where sperm are made with the inside of the man's body, that tube is cut. And that stops the sperm going through. But this isn't ideal for everyone because someone might want a good method of contraception like that offered by a vasectomy, but then they want to reverse it. So what a group of researchers in China have published in the journal ACS Nano this week is a chemical technique where they inject into the tube, which sperm would normally flow along, a series of chemicals that form layers. And actually they say they were inspired when coming up with this idea by looking at a cocktail. Funny that they should be talking about a cocktail when they're talking about a form of contraception. But basically a tequila sunrise where you have a series of different layers where the liquids are at different densities means that you can stack up different chemicals along a glass. So what they've done is to put in a jelly-like substance that stops sperm moving through the tube. Next door to that, they've put another substance which has got these tiny particles of gold in it called gold nanoparticles, which are very good at absorbing heat from infrared. Then next to that, they've put a solution that can dissolve the jelly-like substance. And then next to that, they've put another plug of this stuff which has got gold particles in it. Now, when you inject that sequence, the tube is blocked. And in rats, when they do this, the rats cannot father children, baby rats, they've done this for 60 days in these animals, and they are incapable of having any baby rats. But then they shine infrared light. So this is light which is, you can't see it, but it feels warm. And that light is absorbed by the gold nanoparticles in the jelly-like substance. It heats up the gold nanoparticles, which melts the jelly-like substance, allows the dissolving fluid through, which then completely clears the tube, and then you can return to full fertility. So the idea is this would be a neat way of, with a single injection, doing the same effective form of contraception as a vasectomy, but you don't have to go through a potentially irreversible procedure. It should be quick and simple.
11 minutes after 10. Bradley, good morning to you. What is your science question for Chris?
Good morning, Eusebius. Morning, Chris. My mother was recently diagnosed with colonic cancer, which is unfortunately metastasized throughout the body to the lungs, the liver, the bones, etc. I want to find out what research has been done or is being done, if any, with regards to marijuana and the healing results, or is it just something that's going to make them feel better to live out the last days of their life kind of thing? I'll listen on the radio.
Thanks, Bradley. Chris, did you get that?
Yeah, did Bradley say colonic cancer?
Yes, he did.
Yeah. Hello, Bradley. I'm really sorry to hear about your mum. This is a common kind of malignancy, and in fact, one of the leading causes of malignancy. Now, what happens with colonic cancer, and with in fact any cancer, is that you get a local primary lesion, and that local primary lesion is the one which is where the cancer starts, and it then invades locally. But then the cells that are forming that cancer acquire various genetic changes that endow them with the ability to break away from that parent tumour and then migrate in the bloodstream and also in what we call lymphatic vessels, which are the tubes that drain tissue fluid to lymph nodes. And the cells wander off via both of those routes and can build new tumours in new parts of the body, and that's the process of metastasis. And certain tumours tend to metastasise preferentially to certain parts of the body. And the lungs, because they have a vast network of small blood vessels, and also the liver for the same reason, are quite common sites of metastases. The liver especially with bowel cancers, because the liver is the first port of call for the blood that leaves the intestines. Now, in terms of what we can do about these cancers, then you ask about marijuana, but just upstream of that, the first thing is if we catch some of these cancers very early, before they've gained the ability to start spreading, then sometimes surgery can be completely curative. You just remove the primary lesion and there's no cancer after that. If a person already has lesions that have begun to spread, it might be amenable to what we call chemotherapy. And this is where we put drugs into the bloodstream, and those drugs tend to target cells that are growing very rapidly, which cancers often are, and in that way you can destroy the cancers. If a person gets to the stage where we can no longer hold the disease back, then the emphasis shifts towards trying to make sure they're as comfortable as possible, and this is palliative therapy. And there's a range of different drugs that doctors can give which can help people to feel as well as they possibly can. People can suffer from pain because the tumours can grow into nerves and irritate nerves. They can cause bones to weaken, and this causes bone pain. Well, both of those things can be very well controlled with painkillers. People often also complain that they don't really want to eat very much. They don't feel very hungry, and because they don't eat very much, they don't have enough calories coming in, and therefore their body's robbed of energy, so they feel down and low because they don't have enough energy. So there are also ways to bulk up how many calories people take in, and sometimes some of the chemicals in marijuana can be quite helpful in encouraging appetite. People often talk about the marijuana munchies. Well, the marijuana is stimulating the food intake centres in the brain, and so people use certain chemicals which are derivatives of marijuana, or some people even use marijuana itself, because it can help to restore appetite. And one of the other things that happens in cancers, and especially people who are taking drugs to control their cancer, is there can be nausea. And that can make people feel pretty low as well, and it also stops them eating. And one of the effects of cannabis and marijuana compounds is to have an antiemetic effect. And this antiemetic effect is basically a sick blocker. So people feel a lot less nauseated when they take this agent. So there's a range of reasons why we're interested in some of the natural side effects of these drugs, because we can use them to inform how we make more targeted drugs. And there is a drug, it's called Nabilone, which is a tetrahydrocannabinol-like chemical, and it blocks the nausea centres in your brain, making people feel a bit less unwell, a bit less sick. So there are a range of things that you can do, and either directly using extracts of cannabis, or the chemistry of cannabis informs how we do these things to make people who have cancer have an easier time.
Vicky, good morning to you. Welcome to the show.
Morning. Two siblings, same gene pool. One is super brilliant, the other is just average. How come?
And which one are you? You're not going to answer that question.
Of course.
Well, the answer is that we're all different. We're all individuals, and if you think about unless you have an identical twin, then everybody is genetically an individual and unique. Excuse me. And therefore, just because you are born from the same source genes, the unique gene shuffling that goes on to make an egg and a sperm means that a unique combination of genes makes that individual. That's the first thing. And the second thing is that those genes basically help to create a blank canvas, but then the environment in which you're reared, the aptitude that those genes endow you with, the education you receive, the nurturing is very important too. So two identical twins brought up in two completely different environments might have some things in common, but the potential they'll have in common, but their outcomes will be very much dictated by the environment. It's a bit like if I have a plant, I could have two identical plants, and if I feed and water one of them, I'm going to get a bigger plant than if I deprive the other one of nutrients and a fertile soil to grow in. So that's why you can, with the same genetic stock, get quite different outcomes.
Thanks, Vicky, for your question. Mesh, good morning.
Good morning, Mr. Diaz. Good morning, Chris. So I just wanted to find out whether we are alone in the universe. The second question is the incident that happened at Roswell. Is it true that there were like aliens?
The line's not great there, Chris, but did you get the gist of
his
cluster of questions?
I did. I mean, question one was, are we alone in the universe? And as far as we know, at the moment, yes, but that's only informed by the fact that we haven't had a conversation with an alien. So that means that there's everything to play for. My own inclination is that we are not alone in the universe. The universe is so enormous. It's been here for 13.8 billion years. In our galaxy, our Milky Way galaxy, there's more than 100, well, it's probably 200 billion stars here, of which a high fraction are like our sun, and a high fraction have planets around them. And there's something like a couple of 100 billion galaxies, like our Milky Way galaxy. So there's more than 1 followed by 22 zeros stars out there, all with a clutch of maybe 5 to 10 planets around them, a fraction of which are going to be very similar to our star, and a fraction of the planets around those stars are going to be in the right sort of spot around that star for things like liquid water to exist. So in other words, the right conditions for life. So given the vastness of the universe, the enormity of these numbers, I think it's almost inevitable that life, maybe not life as we know it, but life or life processes are going to exist somewhere else. When we find it, though, that's a different story. Now, the other thing that was alluded to is this story about aliens landing in Roswell. I think the Roswell incident. Now, this is probably a grain of, or some kind of kernel of truth in terms of something happened and it's now been bloated and blown up by lots of speculation and that kind of thing. So we don't know much about this because it's something, it was on a military base, it's shrouded in US military secrecy, and I think probably it's all been fueled by lots of secrecy. Some cynics say that the US sort of fed the fire of people thinking about UFOs and that kind of thing, because when they're doing secret tests of new technologies, you can just write them off and say, it could be a UFO. And then everyone thinks it's aliens. They don't realise it's the next generation of fighter jet or something.
Pedri, good morning. Welcome to the show.
Good morning. My question is about thermal pockets. We fly quite a bit of with the hot air balloons. Now, I want to know why the thermal pockets affect the hot air balloon as we come in for landing. If we go through a thermal pocket, that can push us up quite a lot. But why does that have no effect on us when you walk through that thermal pocket?
Okay, well, what we're referring to here are masses of air which are at a certain temperature and density and are therefore moving upwards because they're less dense, so they're floating upwards, and they're surrounded by pockets of air which are cooler, more dense, and therefore they're sinking. Well, you're thinking about the air above the ground. When we're down at ground level, then the air there is at its densest, and it's also closest to the ground where it's being heated. We're also moving quite slowly, and the size of a human means that the relative distant density of the air we're moving through relative to other bits of air around us is not going to change that much at the speed with which we're moving. But when you're in an aeroplane, it's bigger, so it's spread out over a much bigger surface of air, and it's also moving a lot faster, and so you're encountering these different densities or movements of air, different temperatures of air, much more frequently, so you're going to notice them a lot more. So I think those are the reasons why you tend to notice it more when you're flying than if you're just wandering around at the ground surface, because you're very small and you're moving quite slow, relatively speaking.
Thanks so much for your question, Pedri. Judy, good morning.
Hi, Chris. With the universe expanding and galaxies moving away from each other at such a phenomenal speed, would we ever be able to build any kind of intergalactic spaceship that could actually go to another galaxy, because it's just constantly moving away?
Hi, Judy. You're quite right that the universe is expanding. We know that because of the experiments that have been done over the years. And as the universe gets older, it expands faster. And the space which is expanding is the intergalactic space. So the space that's between the galaxies spread out around the universe. And at the moment, we can't even get to the nearest star in our own galaxy. Apart from our own sun, we can't get to the next nearest star here, let alone try and go intergalactic. Now, the rules of physics don't rule out the possibility that we might be able to exploit various tricks to leap vast distances in space, but at the moment, using what we know of physics, we don't know of an easy shortcut so that we can go from A to B within the lifetime of a human being. In fact, it would take multiple lifetimes, many, many, many generations to go anywhere. There is this phenomenon called a wormhole, and the idea of a wormhole is that there are ways to warp space. So if you can imagine space as like a flat sheet of paper, and I want to go from one side of the piece of paper, I'm holding it on, say, the left-hand side, and I want to get to my other hand holding the right-hand side of the piece of paper, I could go right across the surface of the piece of paper, the full length of the piece of paper. Or, if you imagine I bring my two hands together, I'm going to get a loop downwards in the paper. And the two edges where the paper begins to loop, as my hands come together, are much closer together than if I go right round the loop. And so scientists are saying that theoretically you could create that so-called wormhole, a communication between one bit of the paper and the other to short circuit or jump across that distance. The problem is the amount of energy that you need to do that is so stupendously huge that we don't know where we would tap into that sort of energy and how we could sustain that communication for long enough for us to go through the wormhole before it collapsed. But physics doesn't say it's impossible, maths doesn't say it's impossible, but at the moment we haven't discovered how to do it.
Linda, good morning to you. Welcome to the show.
Hi. Hi, good day to you, Chris and Eusebius. I'd like to know if there's any truth to the myth that using excessive amounts of vitamin B17 can kill off cancer in your body.
Hello. Well, to be honest, one's always sceptical about claims that anything kills off cancer, because you can never say never in medicine, but you should never ever say this definitely will work. The thing is that if it was that easy, we would have cured this problem a long time ago. Cancer is a genetic disease, and it's caused by cells building up damage to the DNA in the cells, which then lead to the cells disobeying the normal instructions that means that they behave the right way. And they have therefore been evolving in your body to outpace, outwit and outstep all of the systems that normally keep them in check. They're an escape mutant, if you like. And the way we'll probably end up solving cancer, apart from with surgery, I think that will still have an important role to play in removing some cancers, is that we will be persuading the immune system to step in and get rid of the cancer. And it's getting there. What scientists are getting closer to being able to do now is to show the immune system what the cancer cells look like and then tell the immune system to destroy the cancer. Because at the moment, cancers use various techniques to switch off the immune system in the cancer. So when the immune system comes in to try and get rid of the cancer, it's told, leave me alone, don't eat me, I'm fine. And what scientists are doing is engineering signals which can mask those don't eat me indicators, so the immune system will nevertheless come in and then help to dismantle the cancer. I think that's going to be the direction it's all going. And the beautiful thing about using the immune system to do this is A, it's naturally part of you, B, it's very good at telling friend from foe, and C, it can access all areas, which means that it can get where the cancers have gone and sneak into places where cancers sneak into, because its cells just like the cancer cells are, and therefore it has the best possible prospect of ridding your body of cancer. I would be very dubious of unsubstantiated claims that giving anything in massive doses will cure something. It probably will cure something by killing somebody.
Gareth, good morning. What is your question?
Hi, good morning. How are you?
Good, thank you.
So my question is, I just wanted to find out, when you are watching TV in your home and you've got the exact same station on in another room, there always seems to be a delay, between the two TVs. Similarly, when you're watching maybe a rugby match and your neighbours, they're cheering on when someone scores a try, you only get to hear that a couple of seconds later on your TV. So I just wanted to know what the delay was, what causes that delay.
Hello, Gareth. Well, the answer to this is it all comes down to the processing. There is some latency in the signal coming off of the desk in the radio studio or the TV studio, because when it goes through the digital equipment, there's a bit of latency. These days, it's very, very short. We've got very good equipment that very quickly processes signals, so that is only a small contributor. There is a transmission delay of the information getting to you. Now, if the information comes down a wire, the signal is coming at the speed of light, pretty much. But if the signal comes to you via satellite, and it's coming from a geostationary satellite, the signal has gone 36,000 kilometres out into space, and then 36,000 kilometres back down to Earth, and then it goes into your TV device. And depending on how good your TV is, there's more latency there, because it has to then recompile the image from the data streaming in and then present the image to you. So all of those things put in a variable amount of delay into the signal, and depending upon how you're accessing the signal and how your TV is rendering or your radio is rendering and processing the signal, there's going to be more delay. And this is why some TVs or some radios, some systems are going to present you with a signal faster than others.
Chris, that's all we have time for. Thank you so much for this week. We'll do it again next Friday.
I've enjoyed it very much. Thanks, everyone. Great questions. See you next time.